Hello, everyone. Welcome back. My name is Hardeep, and you are on the Kubernetes show. This week, we're going to talk about Linux operating system. We'll pick up from where we left. So, if you go on GitHub and search for the hyphen Kubernetes hyphen show, or just go to GitHub and type the Kubernetes show and get into getting started Linux, you'll land on this page. For every video that I'm making, I'm adding links here so that it's easy for you to follow. I'm kind of adding them by numbers. If you get inside every one of these readmes, you'll be able to see a link back to the video. So for the today's video, we'll be talking about major Linux distributions and we'll be building our first Linux VM. All right, with that, I'll click on the link and we'll go through what uh, other distributions or what all Linux distributions are available that you can use. A little bit of history of each, some details like when it started, why it was named that way. Uh, I find it fascinating that most of the folks who have worked with the Linux for years, even they don't go and try to kind of look at the history of a particular Linux distribution. So I included some details there for you. Well, with that, let's get into it. Oh yes, the first thing I mentioned this YouTube video. Since I'm recording this, so this link is not live, but by the time I post it, uh, I will go back and update it. All right. Uh, I got a lot of feedback from a few of my friends. They said uh, increase the size so that it is easier to read on mobile devices. So that's why you might see little larger size. Uh, but still, I'm trying to kind of make it uh, work on larger screens versus smaller screens. Again, I'm not a YouTuber. I'm not trying to make fancy videos, just trying to give back. All right, with that, getting back to Linux major distributions. When we say distribution, if you go back to my last week video, so number two, this is number three file. If you go on number two, I talked about distributions a little bit. Distribution is nothing but a wrapper on top of Linux kernel. Basically, your workhorse is Linux kernel. It's like engine of your car. That is Linux kernel. On top of that engine, you might put a body of a SUV or a sedan, right? So distribution is a packaging mechanism to kind of put all the required files, packages together so that when you run it, you get experience of a desktop or command line operating system. All right, with that, I'll get into Red Hat. So it was created in March 1993. You'll see I mentioned package manager. We'll dive deeper into this one as well. What does package manager do? But I don't think it is appropriate for us to talk about it right now since we are getting started. RPM, Red Hat Package Manager. I have given a link to Wikipedia. It's very easy. You can go and search for it. Interesting fact, right? A Red Hat. How did it got named as Red Hat? Um, there was one of the founders, Mark Ewing. So in college, he used to wear his grandfather's hat, and that hat was of red color. His peers would say, if you need help, look for the guy in the red hat. And that's how it got its name as Red Hat. Interesting, right? Yes, I also found it interesting because even after spending 20 years with Linux, I also didn't know. Before I started recording this video, I was a very hands-on user of Red Hat Linux, but I didn't know how did it got named as Red Hat. Anyways, getting into next kind of operating system. I have listed, I think, four of them, but I'm talking about only major. There are literally thousands of them. You can make your own distribution if you like. Making is not a problem. Maintaining is, bringing in community to support you and work with you. That's the kind of challenge. But what you are bringing on the table that helps to keep your distribution afloat and alive. Anyways, this is Red Hat, very popular since March 1993, uh, because Red Hat is one of the major uh, or operating system service provider or operating system builder. They have enterprise support too. So after Red Hat version 9, so Red Hat named their versions as Red Hat 1, 2, 3, 4, 5, 6, 7, 8, 9. Till 9, it used to be Red Hat only. Somewhere uh, when it was a Red Hat 9, around that time, there used to be another distribution that used to be kind of source for Red Hat. Name was Fedora. So Fedora got renamed as Fedora Core around version 9, and around that time, Red Hat started releasing Red Hat Enterprise Server 1, Enterprise Server 2, and then finally they kind of segregated both of them. Fedora Core got core removed from it, it became Fedora, and Red Hat became RHEL, Red Hat Enterprise Linux. So if you see Red Hat with a version number, you really need to figure out what version they are talking about. Is it, let's say, somebody says Red Hat 7, there is good chance they are referring to Red Hat Enterprise 7 versus Red Hat 7 that was in 2014, 13, you know, no, maybe even, sorry, that was in 2004, 2005. All right, so that is a brief history about Red Hat. Then there is another very popular operating system called Debian. Now Debian again, it's a Linux distribution. It is based on apt. It's a high level advanced package manager, and then a low level at the back end. It uses DPKG. In RPM based, they use Yellow Dog Update Manager, and that recently got renamed or replaced with the DNF. Yum still works, but latest standard is DNF. Getting back to this, apt is the tool that Debian uses to run or install manage its packages. Again, there is a link provider inside. The Debian got named. I knew about this fact, so it is nothing new for me, but for you maybe it is interesting. Debian was uh, Ian Murdoch created name of this distribution on the name of his wife, Debian. And so it was Deborah. How it came to become Debian? Deb was taken from Deborah, and Ian was taken from Ian Murdoch. So this together became Debian. Today, one of the most uh, widely used operating system is Debian. There are distributions that are again derived from Debian. For example, Ubuntu. We'll be using Ubuntu when we kind of start building our VM, but Debian is the source of it. Um, we have another operating system, SUSE. SUSE is, again created in 1994. So you see these, most of these are 1993, 1994, and SUSE uh, also has Open SUSE as well as Enterprise SUSE. SUSE works something similar to Red Hat. Debian, on the other hand, is kind of open source. Red Hat also has sources available, but they have their different licensing mm, scheme. All right, getting back to SUSE. SUSE uses different package managers. They have Zipper, that's what it is called. And they have Yast, uh, yet another software tool. I think that was the name, but anyways. So Yast is there, Zipper is there, and at the low level, it uses same thing that Red Hat uses, Red Hat Package Manager. So the files that it uses to package things together, that is RPM. We'll talk about Package Manager in a bit. Anyways, SUSE is again same Wikipedia you have, and from where the name came from, it came from German acronym SUSE, Mini Software Systems Entwicklung, and that is software and systems development. Right? Uh, Interesting. I also didn't know about SUSE too. I had to do research while I was preparing for this video. The next one is Slackware. This is often referenced as the oldest well maintained open source operating system or distribution. Uh, if you see it, it says July 1993, whereas this is March 94, this is August, but March was for Red Hat. So it should be Red Hat, right? Why this one gets called as the oldest? Because it is based on another operating system. It was Slackware was created to improve a distribution named SLS. Uh, I had, if you go on the wiki, you'll be able to read more about it. Again, uh, this tool has its own history. It uses PKG tools, Slack PKG. It is still maintained. It is pretty amazing to see, how the oldest Linux distribution is still being kept and maintained. Uh, this one is kind of a special use case item that I mentioned. This distribution is very famous, and it is a bootable live environment. Meaning, if you go back to my video number 2 on Linux topic, you'll find that I talked about how you can use Linux. You can install Linux, you can boot Linux, you can look at online systems to use Linux from them. There are the killer.sh, like I have mentioned. I've provided links to in my, if you go on second, this MD file or Markdown file, you'll be able to find the links to that. Anyways, this is live bootable environment without modifying anything on your system. You still will have a full-fledged working, GUI based, even command line based, all tools available. You can use Knopex. I mentioned this because this is very popular, very famous, maintained really well, right? So this was one kind of honorary mention here. The rest all are kind of operating system. Slackware is used by enthusiasts who are more focused on that free raw Linux feeling. It has its own fan following. Then Debian has Ubuntu and few others that people use. But anyways, now with all this, before I kind of move forward with file structure, I wanted to talk a bit about package manager or package management solution. Remember, I have mentioned it everywhere. Every distribution has its own package manager. Now, what is a package manager, right? So package manager is when you want to install a software. For example, most of the users in Windows, right, they get a exe file from a software distributor, or somebody created their software, they want to give it to you to install on your laptop. They don't give you one file, but it's a kind of file which is a zip, something similar to kind of compressed version of multiple files, right? You double click on it, it shows nice wizard, you click click click, select location where you want to install it, and finally it gets installed. uh, so what happens in the back end, right, when you do that click 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 on Windows? It is basically extracting the files from that so-called exe file or zip file and placing those files somewhere in your operating system. Now, what files it are being placed inside your operating system? Those files are maybe required binaries, required libraries. Any package that you run on any operating system, it has its own dependencies. Okay, so those dependencies are what enable a software to run. We will look into dependency management and other things when we get into a little bit more advanced. But as of now, just understand that if you are trying to build a, for example, bird cage, right? Let me try to give you an example. You are building a bird cage for, and you want to build it from scratch. You will go to a hardware store. You will find maybe some raw material that you need for it. Maybe you are building it with a kind of wooden frame. You will need wood, you will need nails to, or you would need glue, right? What all things are getting together to make that birdhouse, right? Or the package. That is what is the process of kind of building a package, right? So package manager is a tool that help you kind of streamline this process. When you deploy one software, it has maybe 10 dependencies. For example, going back to the bird cage, right? If you want to kind of stand the walls of it, then you might have to either nail it or glue it, right? So that's a dependency. You might need a hammer to kind of put the nails in, or a glue gun, or a gun to nail it down, right? So similar story here on Linux operating system or Windows or Mac OS. Whenever you are installing something, you have dependencies. You need something that puts together everything. It goes automatically figures out what things are needed to install a package on your system, because uh, nothing can run on its own unless it is statically compiled. We'll talk about that hopefully during this course. But anyways, getting back to where we were, so hopefully that gives you a little bit about package manager. I would say uh, search this keyword and say Linux package manager and read more about it. I have few links that I'm going to add somewhere in at the end of this file, so that you have some references where you can go and see. You will understand what are the challenges when you are installing any software on your machine, right? So how package manager comes into picture, why uh, it makes sense for Red Hat to build RPMs versus Debian to build deb packages, right? Mm, I'll add some links to it. Now, uh, moving ahead, I wanted to give some idea about Linux file system structure. Now we know there are distributions, but once you get inside distribution, what you face is a 99% of the cases, if you are working on servers in the cloud, you will not be using a web interface, so called GUI, right? Graphical user interface. You'll be using command line interface. So when you are facing command line interface, you need to understand what directory you are sitting in, what is the significance of that directory, why that directory is needed. So that's why I kind of included a little bit here. In Linux, there is a special directory that is slash. This is the root of everything. We call it root because it's like a root of a tree, right? The tree starts from the root. So it is slash. This colon, ignore it. I'm just trying to use it as separator uh, from the definition. That is how I'm kind of using it here. All right. So now root directory is the top level directory. Anything in Linux file system that you'll see is always under root. There is a directory called bin, as name suggests, binaries. It has user binaries. We will see a difference somewhere in the in this file itself. There is bin and there is sbin. Look here. Sbin is system binaries. Now we wanted to, like, the people who defined these standards, they wanted to have this separation where user if user is installing something, it should get installed in its own file system or its own directory, versus going and modifying the components of the operating system itself, right? So that's why it is, sbin is separate and bin is separate. Etc is system configuration files. So if you are installing a software and you want to configure it to function in certain way, you go and define its settings in Windows. All this gets stored generally in a registry. In Linux, mostly it gets stored in etc. Windows has Windows registry, Linux has etc directory where you'll find all this. Home is home directory for users. In Mac OS, it is, I think, slash users and username, and then that's where you see the content. But in Windows, it is C colon slash users and then user name directory. Similarly, in Linux, there is slash home. Inside slash home, you will see a username. Like if user is Ubuntu, then you'll see slash home Ubuntu. If username is Hardeep, then it'll be slash home Hardeep, right? So that is how users home directory are segregated. Then we have USR, user utilities. Again, this is part of this only, something similar to bin. User utilities and applications are generally available in USR. Then where variable data, where data continuously keeps changing. For example, system log files. Right? In Windows, you have event viewer, but in Linux, Unix type operating systems, you will find where file system. The where file system is where your log files are kept generally. Again, this operating system Linux gives you ability to kind of store data anywhere where you like, but we have standards, and that's what we are talking about here. Following standards make life easy for everyone because you are now using a common lingo or common structure of the file system so that others can also understand who are working with you. Anyways, looking at this temp directory, this is for temporary. Anything you write in this, if you reboot your system, you'll lose it. So don't store anything important. Dev is device files. We'll dive deeper into it maybe in later chapters. These are devices like this microphone or your screen, your hard disk. Everything is a file in Linux. So remember, anything, even your screen, your keyboard, is a file. Linux knows file only. Anything that you use is a file. Keyboard is a input device. It is taking input from you and writing. On the display you see that is a output device. That's where, again, it's a file taking input from keyboard, showing it on your screen. One file is getting read, another file is getting written. We'll talk about input, output, and all that in coming videos. As when system binaries live essential libraries, media, removable media. Now, this media is kind of a recent addition to the Linux file system structure. Media is, for example, you insert a USB drive on a system where you are running Linux. It'll get mounted in media, maybe USB 1. Mounted means you will be able to see the content of that pen drive, right? If you are inserting a maybe CD-ROM, then it'll be media CD-ROM, right? Uh, so that's why this is a removable media. Pen drive you can remove, CD-ROM you can insert and remove. So this is removable media. MNT is mount points. Uh, I've seen people use this as temporary location where they mount, but in older times when standard was getting defined inside MNT, you will use this directory and have subdirectories under it where you will mount file system from remote servers. we will get into what does mounting means, what does remote servers means. But for now, keep in mind that MNT is mount point, then OPT is optional software, root is now this. It becomes a little confusing here, right? It says slash root and this is root. In Linux there are multiple roots. Now this is root directory, just keep this portion in mind. This is directory, root of file system structure, that is root directory. This slash root is home directory of root user. Now what is root user, right? A root user is user inside Linux system. Every Linux system has a user named root. That root user is owner of this directory. If that user need to log in, that user logs in and lands into slash root directory. So when we look at normal users, they go inside this slash home slash ubuntu slash home slash hardeep, right? But root always goes into slash root. This is home directory of root user. This is most powerful user in the system. It has power to destroy the system, create, install. It can do so many things, right? It is very powerful. I'll end it here, but we'll talk about root and what is the difference between root user and normal user. Proc is system information. Whatever you are running inside the operating system is shown inside proc file system. When I say running, for example, you are running a process. That process has some environment variables, which directory it is running from, how it is interacting with files in the system. All that information is in proc. How your kernel is doing, what were the boot time logs and all that. That information also you can find within proc. Proc is very powerful. You have a raw access to the running Linux system with proc. Keeping it safe, secure is very important, but I'll not get into kind of details into it. But anyways, so let's try to visualize the file system that I have been talking about, right? So this slash is our root. Remember I mentioned slash. This is our root directory. Everything is under it. For example, slash bin, right? This slash is there on top. Slash etc slash home slash user slash war slash temp, right? I've added along with this image little bit of description of everything. Then under root you have other directories to uh, bin, lib, media, mnt, right? So this graphics is just to kind of show you how does it look like when you look at Linux file system. Now, there are some special file systems too. There is dev file system, then there is sys file system. It talks about what kind of files it contains and what data it has. Let me go back. And yeah, well, you can read more about it. But with that, I think we know enough about what file systems are or what directories are there in Linux. So we talked about Linux distribution, a little bit history of each, what are some very popular distributions, what Linux file system structure or LFS, Linux file system standard is, what each directory means. We talked about some special file systems, and finally, we are looking at our very first Linux VM install. I, if I recall from my previous video, one of the users mentioned that I should show how to do the installation on Windows using WSL. I can do that, but I wanted to kind of make it very easy for everyone to follow. So we are going to use a utility called multipass. If you open this link, it opens into this page. You can see it works on Linux, Windows, and Mac OS. Why am I doing this rather than doing, uh, you know, uh, WSL? WSL will make me work on Windows only, and I cannot port the WSL on Linux or Mac OS, right? So I wanted to provide a common platform for everyone. You go run one command and you have a VM. That's the idea, right? How do you install it on Windows? It is you can download multipass and you can run the installer, right? And this is how you launch your VMs. This is by Ubuntu. uh, Very advanced topic. It has cloud in it and many other features, but I'll not be going into details. I'll show you how does it work, right? So let's start with this. So I have installed it on my system. So if I say multipass list, you can see there are three VMs running. I'm running a Kubernetes cluster, but um, I'm not trying to show you how Kubernetes cluster work. But if I say multipass help, you can see it has many kind of sub commands. Linux, it is a kind of standard way of looking for help is command and do hyphen help or hyphen help or hyphen h, right? That's it. And you'll be able to see some information. All right. Before I did this, I was playing with it and I ran some commands here. I wanted to kind of not waste time during recording of this video. So what I'm doing is multipass launch. I'm doing verbose. I'm giving it two CPUs. I'm giving it 1024 MB memory, and I'm giving it a name as Learn Linux. So if I run it, you can see it says starting Learn Linux. First, when you are running on your system, it'll say it is downloading, then it'll say it is starting. It is downloading because it downloads a image from Canonical's website or Ubuntu Linux website. So what it is doing in the backend, it first downloads the image, then it creates a virtual machine and then boots up that virtual machine for us, and we will have a working fully functional virtual machine where we can go learn Linux, run commands, do whatever we want, right? So that's the idea. All right, so it is starting this Linux virtual machine. I got already three running. I should have stopped them, but anyways, let's look into what am I gonna do next, right? How do I kind of launch instance? This is something similar we saw. How do I run a single command inside that machine, right? Which I just launched. So if I had this launched as foo, I can say multipass exec foo. This hyphen hyphen is kind of your input, and you are saying go inside this system and run this command, right? You can run multipass list. You can do start, stop, delete, purge, right? All this. Again, I was talking about that cloud init advanced user functionality. You can do that, read about it. It's very interesting. Anyways, let me get back, and it says waiting for initialization to complete. So it means it has downloaded the image. It created a VM already. Now that VM is booting up, right? That's what it meant by waiting for it, complete. So if I run list, you see there is a new machine, and this is the IP. If I say ping, and I'm able to ping, great, I have a VM, right? So now let's see what else can I do. I can do this and hyphen hyphen uname hyphen a. So it is logging into Linux system and running that command inside that. Because if I run this command on my laptop, you can see it says Darwin versus this one, it says Linux, right? It says MacBook Pro, my laptop name. Now here it says Learn Linux, and you can see it says Ubuntu, it says Darwin. So there is difference. This command ran on my laptop versus this command, it went inside that VM and executed there. All right, so this is nice, but how do I get a shell inside it, right? So right here it says shell, right? So if you are copying files or doing something, you can literally use the thing that I was showing, exec. But if you want to get inside that VM, right, and want to execute commands inside that VM, you can do multipass shell. And look at that, I'm inside Linux machine, and it shows you the details. It says welcome to Ubuntu, and that's it. And you can see if I say uptime, it is up from 3 minutes. It says there are two users because there was another login session from me when I did that exec. I believe it's from that time, but anyways, what we see here is we are logged into a Linux system. And let's see if I do. I'll talk about the sudo as well, but before I do that, first let's understand what this prompt is from end to end, right? Because when I landed inside this, I landed here. Now, first thing is Ubuntu. Ubuntu is the username. Okay, so let me get out of the sudo and say, who am I? It says Ubuntu, right? Who am I is a command. The command tells you what is your username. Then next one is at. At is just a symbol. And next is where that command is running. It's running inside machine, and machine name is learn Linux because that's what we named it. And this column, again, it is part of the prompt only, this tilde character. So let me show you something. We go into temp, and if I say cd tilde, I land back into the same directory. So if I say pwd is print working directory or present working directory, right? This shows me I'm in my home directory. So this tilde is home. You can literally say cd home of ubuntu, right? Take me back to the home of Ubuntu. For example, if I go to temp again and say cd tilde Ubuntu, it takes me back to home directory. So I can do pwd. All right. Now we know what this tilde characters means in Linux. Now next is this dollar sign. This dollar sign, you will notice one difference here. This, for a user it shows dollar sign, for root it shows hash. This is how, just by looking at prompt, you say whether that user is a normal user. Normal means non-root user, user which doesn't have administrative rights, right? It might have but not full rights as a user directly itself, right? For example, here it says dollar, it means it's a normal user. But if I say sudo su hyphen, now I am root. You can see it says root. And if I run this command, who am I again, and you can see it says root. Now let's see, if I run this command again, cd home of Ubuntu, what happens? Look at this. I landed in that directory, home Ubuntu. You see this? Yes. If I do cd this, what will happen? I land in slash root. How do you know where you are sitting? pwd slash root, right? Print working directory. All right. With that, we have enough information. But what I wanted to show you is this. lsl. So this is your top level directory, and anything inside it, what I did was lsld and star, right? So it is showing me this is top level directory. Inside that, all the directories that we talked about, there is boot directory, dev, etc, home, lib, right? We talked about almost all of them. We'll talk about these permissions because now we have a working Linux VM. You'll be able to run these commands on your side too. I want you to make this at least work. Then very next thing, I know we talked in past video as well that we'll dive into this one, but what I realized that you should have your working Linux VM too. Why VM? Why not laptop? Directly on laptop? Because I don't want you to mess up your laptop. This VM is a perfect playground where we will mess up things, we'll delete things, we'll change permissions so that you get enough hands-on experience. And with that, I will be ending my today's recording. During next video, which will happen after one more week, because next week I'll be recording for my advanced users, right? We will slowly start getting into file system permissions. We will know more about what happens when you are running certain commands. What a file system means when when we run commands like this, it says df hyphen h, right? It says 2%, 48%. What all this means, what this dev sda is, maybe we'll get into kind of advanced topics a little bit, but this should have given you enough idea about what linux is, how does it run. Now if you want to get out of it, just say exit once more, exit, and you are out. Now it is eating your resources if you are running it. So you do multipass list, you can do multipass stop your VM. It will shut down that VM. That way you don't need to kind of build your VM from scratch. But if you don't want to do it, you can literally do this. I'm gonna do it because I have enough resources available. But look at this. What happened? It says deleted, right? How do you get rid of it? How do you remove it? There is a command, uh, multipass purge. Purge will purge anything that is not used or which is already deleted, right? Anyways, purging, you can read more about purging, but this is how you get rid of that VM so that it doesn't eat your memory, CPU resources, or battery, right? Uh, when I run that command again to create VM, we will have a fresh VM. If I have messed up something with the VM, I can literally start from scratch. With that, I think we are done recording for this week. I'll see you week after, because next week I'm recording for my advanced users, and I'll see you after that. Take care. Uh, Goodbye. I'll see you in 2 weeks.